Hello. Can everyone hear me? Good. Barely. Okay. I'll speak up. I'll surprise you all. Hi, everybody. I'm Julia Spalding Beagles. I'm the manager of adult and children's programs here at the Denver Museum of Nature and Science. Thank you all for coming today. We are super excited for August 21st, and I hope you are too. Before I introduce today's speaker, I just have a couple of friends in the back to introduce. So when you come on our bus trip, you're going to have one of our educators or astronomers on your bus along with one of our staff as your guide. So in the back here, we've got Mitch and Jose. Mitch in the green and Jose in the black, who are two of our educators. You may also see them in various other forms as Jesse in the planetarium or the Mars astronaut or even a Viking. So they are multi-talented folks back there. And then Jessa, leaning against the wall there, she's our adult programs coordinator, so she'll be the guide on one of the buses as well. So you can look for those friendly faces when you arrive at 4 a.m. on August 21st. And we'll try and bring some caffeine pep for you in our faces, if nothing else. So it's my pleasure to introduce Vicki Sahami. Vicki is an astronomer and also the owner of Sirius Travel. So Vicki started Sirius Travel back in 1999, and she has taken tour groups all around the world to see 10 total eclipses. So this is going to be her 11th. And luckily for us, Vicki and Sirius Travel are based locally, so it was just the perfect partnership to bring her in to work with us to get this tour going for you all. So I'm going to go ahead and let Vicki take us through what a solar eclipse is and what you can expect on August 21st. Thank you.
Good afternoon and welcome, and thank you so much for taking the time to come here today. This is, I know that we have several talks that you were able to choose from, and this will make your day, the day before the eclipse, a little bit easier so that you can get your rest the night beforehand. The museum, as most of you are probably aware, is leading 5 busloads of people, so you'll be in good company on the very early morning. And the museum is asking that everyone park in the very lower level of the parking structure so that the regular visitors to the museum have a place to park during the day. As you all know as well, you've been receiving the emails. The buses are going to be here at 4, so we're asking everyone to be here by 3:45 in the morning, which I apologize. I realize how early that is. If it's any consolation, the guides are going to be here at 3, so they'll be much more cranky. Anyway, so I'm here today to give you a brief talk about solar eclipses, and this is kind of to get you up to speed so that you know what to expect. And how many of you have seen a total solar eclipse in the past? So we have some eclipse chasers in the crowd, and of those of you who have seen them, how many of you went to some lengths to convince your friends that they should see one as well? Yeah, because it's almost like a cult. But anyway, you're in good company here tonight or today, as I think everybody is either an eclipse chaser already or soon to be an eclipse chaser. So, what is a solar eclipse? Now, this may seem like an obvious question, and most of you feel like you may know the answer. The solar eclipse is basically the shadow of the moon being cast onto the Earth. And I like to use this graphic, but whenever I use this graphic, I always feel like I have to warn you that this is not to scale. If it is to scale, and you ever see the sun this close to the Earth, you should just get off the planet immediately, and you'll be fine. But when we look at a solar eclipse, it's essentially the moon's shadow being cast onto the surface of the Earth. Now, the sun is not a point source of light, and so the shadow that it casts has different parts, and one of the parts is the deepest part where all the sunlight is blocked, and that's the umbra. And the other part, the wider circle here, is the penumbra. And you see different things, obviously, when you're in the umbra versus the penumbra. The umbra, for example, can only be up to 75 miles wide at any given time, and so yes, it travels across the Earth, but you have to be within that 75 miles in order to see totality. When you're in the penumbra, it's a much, much larger area. For example, the penumbra would encompass the entire United States. In fact, for this eclipse, because it is central across the United States, the penumbra does encompass the whole United States. So everyone in the lower 48, can see a partial total eclipse. Now I do this one to confuse, because now the sun is on your right. So you have to imagine the sun over here. And here you have your umbra, your penumbra, and this red path as the Earth rotates and the moon moves in its orbit and the shadow is cast on the planet's surface. It's a very difficult path to calculate, but we are able with modern computers to calculate it very accurately, hundreds to thousands of years in advance. Obviously, a three-body system requires refinement with time, but for the most part, in our lifetime, certainly, we know where all of these eclipses are going to happen in the next 100 years. And the path of totality is the red path, and then, of course, the Earth's orbit around the sun, or the moon's orbit around the Earth, and the Earth going around the sun, which I'll talk about in just a moment. And again, the path of totality is no more than, I said 75 miles. It's 92 miles. That's the maximum. And I'll talk to you a little bit about why that happens, and that varies. So, a common question that you might have when you start to realize that solar eclipses happen when the new moon occurs and the shadow of the moon casts on the planet is, why don't we have a solar eclipse every month? The reason for that has to do with the plane, the Sun-Earth plane, as the Earth goes around the sun, and the orbit of the moon. The orbit of the moon is tilted by approximately 5 degrees, which means that it doesn't always line up. A lot of times during a new moon, you'll get the shadow of the moon casting above the Earth or below the Earth. And then also, sometimes the shadow, if it does cast, it's in a very inconvenient location, like in the middle of the ocean or in Antarctica or something like that, and people don't necessarily want to go there. But this time it's really convenient, so we're very happy about this summer. So there's different types of solar eclipses. There's essentially 3. You have partial solar eclipses, you have total solar eclipses, and you have what are called annular solar eclipses, which are actually quite interesting. A partial solar eclipse is essentially when you're in the penumbra of the shadow. And just as a reminder, the penumbra is the outer ring here, the lighter gray, where you're just getting part of the sunlight, not all of the sunlight. It looks like a cookie with a bite taken out of it. And depending on how close you are to totality, you get a larger or smaller bite out of the sun. A total solar eclipse includes partial eclipses, and then in fact goes through about an hour's worth of partial phases, just getting more and more obscuration of the sun until you reach a phase called the diamond ring. Now, the diamond ring is actually also Baily's beads, but it's just one Baily's beads. And we call it the diamond ring. And then you have totality after that. And then once totality ends, you have the diamond ring again. And then after that, you have another hour or more of partial phases until finally the moon moves off of the face of the sun entirely and the eclipse is finished. So from beginning to end, it's a little over 2 hours. The phase of totality is very, very brief. The partial phase is when you're in the penumbra, and these are in the total eclipse cycle. Then the diamond ring. Why does the diamond ring happen? It essentially happens because there's one valley on the edge of the moon that's lower than all the other valleys, and the sunlight peeks through that valley as just the last bit of sunlight that reaches out, and then the moon moves over that, and the entire sun is gone. As soon as you see the diamond ring, that's when you can take the glasses off. And we'll talk about eye safety as well. Totality, this is what we're chasing. Totality, this is when you're in the umbra, the shadow is moving over you at over 1,000 miles per hour, and it's one of those things. It's a once in a lifetime event. The first time I saw an eclipse, it really took me by surprise. It was almost like someone had punched a hole in the sky, and it was a visceral feeling of just almost shock, I guess. I don't know. It's hard to explain. Something I'd never seen before. And then, of course, as soon as I saw it, I knew I had to see more. That's the problem. So what is an annular eclipse? This is the third type of solar eclipse. An annular eclipse is basically when the shadow of the moon does not quite reach the Earth. And why would that happen? Well, the moon and the Earth the moon is on an elliptical orbit around the Earth. And because it's on an elliptical orbit, it's sometimes closer and sometimes farther away. Well, if the eclipse occurs when it's farther away, the shadow literally does not reach the Earth. You can get underneath it, but you can't be in it. And so when you're underneath it in what they call the antumbra, then you see a ring. And why do the eclipses occur? Essentially, the angular size of the moon can vary quite a bit in the sky. And you never see these moons together in the sky, obviously, but if you take photographs, you can compare them. And so you can see that if the eclipse occurred when the moon was at its farther point, it would be quite a bit smaller, and in fact, it's smaller than the size of the sun. We have a unique matching of size in our sky with the sun and the moon. They're both approximately 1/2 degree in our sky. And because of that close match, we get these beautiful eclipses that can show the atmosphere of the sun very nicely, as well as the chromosphere, which is just the inner part of the outer atmosphere. If the moon was much larger than the sun, then we wouldn't get that beautiful composition of the chromosphere with the corona. So that's the details of an eclipse. That's what an eclipse is and what you can expect to see. But what is it that you would actually experience if you go to see an eclipse? Now, there's 4 technical parts of the eclipse. You have first contact, second contact, third contact, and fourth contact. Very imaginative names. And first contact is when the partial phase begins. The sun is first touched by the moon. And you can see it quite clearly, even with the glasses. It's very obvious when that happens and when that starts. And then it takes a little over an hour, but slowly the moon moves across the face of the sun, making these a very clear bite out of the sun. And eventually you get to second contact, which is when the leading edge of the moon reaches the far edge of the sun. That's when the diamond ring happens. And that's, I've been to 10 eclipses. I've seen 5 engagements minimum. So I expect a few more on this trip, because that's a classic time. Yeah. Because it's a diamond ring. And then in between second and third contact is totality. And when third contact happens, you get another diamond ring on the other side of the moon. And then you get fourth contact. And by this time, all the celebrating has started. The only people still watching are the people photographing. And everybody else is on the bus. So every total eclipse begins with a series of partial phases, which may last an hour or more. And the total phase or totality never lasts more than 7.5 minutes. And it's for the same reason that we get an annular eclipse. If the sun and the moon and the Earth positioning is when the moon is at its closest distance to the sun or to the Earth, then you get the largest shadow. You get the deepest eclipse and you get the longest eclipse. The maximum that it can be is 7.5 minutes at this point in our history. As time proceeds, as the millennia pass, the moon is slowly receding in its orbit, and eventually this time will get smaller and smaller until someday, very, very far from now, eclipses will no longer happen here. We'll only get annular eclipses, but it's quite a distance away. And there's some argument that the sun actually may expand by the time the moon gets far enough away. So all the calculations are moot at that point. So these time series that I'm about to show you are photographs of an entire solar eclipse. They're lovely. If any of you are ever interested in finding these, I recommend looking at a website called the Astronomical Photo of the Day, called APOD. It's been in business it's not a business venture, but I think since 1992 maybe. And I don't think they've actually updated the website since 1992, so it's still very 1992. But it's got all of these astronomical photos of the day, including things like this. So this was an eclipse time series that was taken, it's about 10 minutes in between, maybe 5 minutes in between each picture. And then at totality, they took off the filter and got a picture of totality with the lighting on the ground. This was in Easter Island. You cannot tell where that one was. And it's fairly close to the equator, and so you can see how the sun was moving in the sky at that time. I was in that crowd down there. It was really nice. See this cloud? See that cloud up there? Caused a tremendous amount of stress. You have no idea. It looks nice in the picture, but it wasn't. This is in Africa in 2001. This is a photo that was taken by Fred Espenac. And I got both of these off of the first. Yeah, both of these were from APOD, and this one as well, actually. This was Svalbard. This was the last one that I went to. This was above the Arctic Circle at over 80 degrees north, furthest northern university, and also the jumping off spot for polar expeditions. The seed bank is in Svalbard. They're running into problems because of melting, so they're having some issues now. But the whole time during this eclipse, it was 5 degrees below zero when the eclipse began, and then dropped several degrees during the eclipse. All the equipment was failing because the batteries were dying. So people who didn't have heaters were in trouble. And then they had snowmobiles ringing us the whole time to keep the polar bear away. So that was kind of fun. Which sounds like, what's the need with so many people? Well, actually, somebody had been mauled by a polar bear the day before. So an eclipse chaser. I'm just saying, we will not have that problem this summer. We're going to have a whole different set of problems. So eclipse shadows and sharpness. What do you see during totality, and what can you see during an eclipse? One of the things that's noticeable is are the shadows on the ground. Now, we are going to a place that has no trees. Are all of you traveling with Sirius Travel and the museum? Any of you are here that aren't? No? Oh, a couple people in the back? Well, the site that the majority of you will be at has no trees, so this is going to be a little challenging to see. But people will often bring paper with holes punched in it, or a colander, or anything really. You can even do it with your fingers on your hand. But you're basically looking at pinhole camera images on the ground, and if you do that, you'll see little arcs of the sun as you go into totality. And it's the same principle as a pinhole camera. So this is a picture. It's a little hard to see, but this is looking at light through a tree. On a normal day, any day like today, if you go out and you look at the light on a sidewalk underneath a tree, you'll see all these little circles. You're basically looking at little solar images. 100 little solar images. During an eclipse, they turn into crescents. And if it's an annular eclipse, you get rings, which is really cool. Yeah. Now, another thing that happens is your shadow gets very sharp. The reason for this is normally, under normal circumstances, the sun is a disk. It's not a point source of light. And we, on the Earth, as humans, are accustomed to this. This is what we're used to seeing. When it turns into this, it contributes to what people call an eerie feeling. So not only is the light level dropping, which you don't, with your eye, you don't actually normally notice until it's about 90%, but the sharpness of the shadows, I think, is even a bigger effect that people don't really think about or realize until they're looking at it. Now, there's also something called shadow bands, and I added this picture. There was another picture that I found, but it's very difficult to photograph shadow bands. I had a hard time finding a good photograph of shadow bands. This is an artist's picture from the Renaissance, I think. This was in my textbook when I was studying astronomy back in 1980s. So this is a very old one, but essentially shadow bands are things that look like you're looking underwater, at waves under the water on the bottom of a pool. And you can see the approximate scale. They're fairly large. So if you have a small white sheet of paper, you might not see them. But if you have a large, blank, flat surface to look at, like the side of a building that's been painted white, or a sheet on the ground or something, you might be able to see them. So I know people try to see them. But the biggest problem with shadow bands is that they happen right before and right after totality, which is the last time you're looking at the ground. You're just looking straight up. So that's why they're normally missed. And then again, the environment we are going to be in doesn't have large white buildings or sidewalks or anything for us to look at. So people are going to have to bring their own thing to try to see them if they want to. So in the last seconds before totality begins, the remaining bit of sun resembles a dazzling jewel as the ring-like corona appears. And, you know, you can never look at too many photos of a diamond ring or the corona, so I just populate this talk with many. And then you have totality. And so what can you start to see? During totality, it will get dark. It will not get like midnight dark. It'll get like twilight dark. Depending on the depth of the width of the shadow on the Earth will determine how dark or light it will be during totality, because you are that far away from a sunlit part of the sky. And so it's going to be similar to twilight, and you will be able to see stars and bright planets, or planets and bright stars. And in fact, during this totality, the sun will be almost on top of Regulus in the constellation of Leo. So if any of you had any question whether or not you were a Leo on August 21st, it should be abundantly clear during totality that the sun is in Leo. The planets will become visible as the disk of the sun is blocked by the moon. And then during totality, you see these red prominences, which are basically hydrogen flares coming off the surface of the sun, and that's in the chromosphere. It's called the chromosphere because of its color, chromo for color. And they named it the chromosphere because it has those brightly colored red flares coming off the sun. And the photosphere is the part that's blocked, which is the part that you have to protect your eyes from. And then the wispy corona. And every corona looks different. There's no way to predict exactly what it's going to look like. For a long time, people thought that solar minimum meant that it would be a smoother corona. But it turns out that solar minimum has more activity in the corona. And so we're heading into solar minimum. We're sort of halfway between solar max and solar minimum. So we may see some sunspots on the sun. I haven't looked at the sun recently. I don't think there's a lot of activity right now, but we're a couple of years away from minimum. So we might get some sunspots, and we'll probably get an active corona. And what you might experience, again, the eerie word. A lot of people use the word eerie to define what it feels like coming into an eclipse. And then bright stars and planets are visible, animals and small children. I have to always add the small children part because I took a 1.5-year-old to an eclipse and he fell asleep. And even though it was very exciting, a big crowd, a lot of people, but he fell asleep as soon as it got dark. And then the animals will perform their evening rituals, and the temperatures drop, and a wind flows toward the cooler regions in the shadow, just like the Terminator at sunset. You get the wind at sunset and sunrise. It's the exact same effect. Now, this is an image of what the sky is going to be showing us during totality. And you can see here, they had to actually expand it because Regulus is going to be really close to totality. So the star that you see right next to the eclipsed sun will be Regulus. And Regulus is the heart of Leo, the lion. You can see the backwards question mark. I believe it's a red star. Is that correct? Does anybody remember? I think it's a red one. Red giant. And then Mars is right here, and I believe that the color is matching between these two. And then you have over here Jupiter, fairly far away, and Venus. And what I'd like to point out also is Mercury. Mercury and Venus are about the same brightness. So this was something that I did not expect the first time I saw an eclipse, but I was pretty surprised to see. But Mercury is a very, very, very bright planet because it's so close to the sun. And we never see it that way because we're always looking at it at twilight right on the horizon through a lot of air, and it's always bright sky, but it is actually very bright. So that's what you can expect to see in the sky. So, you want to chase eclipses. How would you do it? First thing you would do is you'd start with a map that looks like this, compliments of NASA, thank you. And you would ask yourself, so how easy would it be to get under one of those blue lines? This is a map of total solar eclipses. And you can see it goes out for several years. The next one I show you will include the annulars. But the one this year is August 21st. You can see it's a little thinner than the one that's going to happen in 2024. The thickness tells you the shadow size, so that means it's a longer eclipse. Ours is 2.5 minutes. Remember, it can go up to 7.5. The thickness of the lines on the bottom and the top are deceptive because, of course, this is stretched to make it into a rectangle. The next one after 2017 is 2019, right here. And the only land it goes over is South America, followed in 2020 with a similar scenario of only going through South America. 2024, we get another one through the United States. And then if you throw in the annular eclipses, and the hybrid is a mix between an annular and a total. So because of the position of the moon and the Earth, and when the shadow comes over the Earth, it has to cast a farther distance down at the beginning and the end of the eclipse. You can get these hybrids, which are very short eclipses when they're total, and in fact they're annular at the beginning and end as they cast off the edges of the planet. So yeah, there's a lot of eclipses happening. So you'd ask yourself, well, how can I get to the next one, which you find out where it's going to go, and then you want to look at the path of the eclipse, wherever it falls on land or maybe sea if you have access to a ship, and you want to see whether you want to chase it. In a lot of cases, since we've been doing this since '99, some of the things that we have to consider, which may not come to mind right away, especially since we're looking in the United States, but you have to consider the geopolitical situation going on where you're going, because some of the places where the best viewing was possible, they were having civil war. And so when it came time to decide whether or not we wanted to go to a small country that was apt to get you shot, that's what we had to consider, was how safe would it be. So we don't have that problem this year. Yay, super excited about that. And so then you want to take a look at the path. And in this path, what is the best place to view it? And that's when you start thinking about weather. And you take a look at the date, and you take a look at the historical weather, and I'll show you what that looks like. But in our case, for Sirius travel, we're actually taking people to 3 different locations. We're taking them to Carhenge in Nebraska. We're taking them, your group is going straight up north to Douglas, Wyoming, and then we have another group at a dude ranch out in western Wyoming. Now this is what our destination looks like in Wyoming. Isn't that fabulous? So there are no fixed services here. I would like to make that very clear. But we are bringing in porta potties, and we have the buses, and we have a vendor from Douglas who's going to come down and have things for sale. So there will be things. The buses, there's a little corral for cattle over there, and the buses are all going to park on that side, and then we have about a half a mile to roam on that side, as well as the road up to the little hilltop there, because the shadow will be coming from that direction, the west. This is Carhenge. If you've never been, you should go. It's a riot. And they are so excited. I just talked to them yesterday. They're expecting up to 30,000 people, which is probably more than have ever been to Carhenge combined. And then you start zooming in on your map, and you start to say, all right, well, I think Wyoming is a good bet because it's dry. The eclipse is going to happen in the morning. We know what the weather patterns are like. And so then you look at it a little bit closer. Now, originally, and I heard some of you talking about this beforehand, we had planned to go to Glendo because it's a state park. It has a lovely lake. It's a very nice spot, and it's due north. It's just right on I-25. And then we started talking to the people at Glendo, and we went to Glendo, and Glendo has a single lane entrance. And then it opens out into the big state park, which is beautiful, but if there's clouds and we have to move, there's no moving out of there. I mean, that's going to be the biggest traffic jam of all. In fact, this is my greatest concern. We can talk about traffic afterwards, but my greatest concern coming up from Denver is traffic in this area, because I think there's going to be a lot of people targeting Glendo, and they'll be trying to get off the highway, and there's going to be some difficulty there. But you can see that I-25 runs right across the line of totality, so it bends over here to Casper. That's all I-25. So there's a lot of access. It's really great. And Wyoming Department of Transportation is aware of the situation, and they're going to suspend all of their construction for 2 days beforehand. Yay, I know. I was really excited to see that. And so then you zoom in a little bit more, and you can see where the exact center line goes and where the maximum number of minutes is. We like to go for the middle if possible, and we are going to be right there. 2 minutes and 29 seconds. And then you might look at the weather statistics. And so these are weather statistics that are published by Jay Anderson, who is based in Canada. He's been doing this for a very, very long time. He is actually retiring, and I don't know how much longer he'll be making these predictive maps for weather, but I know that NREL is picking up the ball on weather predictions, and they have a new weather forecasting that they're doing. I'll be actually talking to them on the 9th. I'm going to go down there next week. But here you have the weather prediction in the morning is the red line, and you can see we're in very good shape, the best possible shape on this in Wyoming, and eastern Oregon is here. Obviously, bless you, sorry. Obviously, it is, it's never a sure thing. It's one of the reasons that causes the most stress for people is the possibility of clouds during a total eclipse. And so we do try to make plans for mobility if necessary, but sometimes there's not a lot that can be done if it's a very uniform cloud cover. But we're hoping that this is going to be a very typical day in Wyoming on August 21st, which is going to be blazing sunshine through noon, and that's our hope. So eclipse safety, we always like to talk about eclipse safety. It's very important. We will be giving you eclipse glasses that look like this. They're cardboard. They fit over glasses. I always wear them over my glasses, and then when I'm not using them, I just park them right here. It's a very good look. And and they're always there, never lose them. And we'll be providing everyone with a pair of glasses, so you will have that. These should never be used behind anything. So if you have binoculars or if you have a telescope, you need to be able to filter at the front of the optic. And the reason for that is that the optics will focus light, and so binoculars will collect more light than your eye and will focus that light onto a little spot, and that spot is where you would normally look through the binoculars. If you have these glasses there, that spot of focused light will burn right through these. And that has happened a lot. And so I do caution everybody, please only use these with your eyes. If you have binoculars, you should either have filters for the front of your binoculars, or if you don't care that much about the optics of your binoculars, you can use them to focus light onto a piece of paper and then watch an image of the sun on a piece of paper. So, but never ever use these glasses with other things on top of them. I talked to my eye doctor about 2 weeks ago, and he said, yes, I've seen sun damage, and it's not good. You don't want that. These are what the filters look like. At this point, I am sorry to say these are probably difficult to come by, although I think they sell them in the museum here. You can get some of these in the museum, although, like I said, we will be providing our group with them. But filters like this, you can order. They're fairly inexpensive. They're usually just a cardboard ring with the filter material. But at this point, because of the popularity, I have seen that it's hard to get them. So hopefully you already have the ones you need. This is what you look like afterwards. Super happy. Because you see, there are hardly any clouds. This was Mongolia, which interestingly looks a lot like Wyoming. We didn't see anybody. There were no cities or anything, but these folks they were wandering by. They knew we were there. Everybody knew we were there. They all came by to visit. Upcoming total eclipses. So once you go to this eclipse, the first thing you're going to say is, all right, where's the next one? Because I need to start planning. And the next one is July 2nd, 2019, in midwinter in South America. So the weather statistics are a little bit iffier there. But we're taking people down to the one of the clearest places in the world. It's got all these telescopes that they have there. It's Cerro Tololo is down there, and it's right near La Serena in Chile. And then December 14th, 2020, again down in Chile, and then December in Antarctica, and April 20th in East Timor and Papua New Guinea. The fun thing about going to see eclipses, if you've never done it before and you decide that this is going to be your new thing, is it gets you to places you would not normally go. It's you have a list of top places that you'd like to see in the world, maybe Paris, maybe London, maybe, someplace a little bit more unusual. But East Timor is probably not on your list. But if you chase eclipses, you might end up in East Timor. So, just saying, it's fun. So we're going to be going down to South America, and I have to throw in a little picture of Easter Island because I can't wait to go back, and we're going to go there as well. And this is our business. These are some references, and if I can put this back up at the end. But before I stop, I wanted to play this brief video. And this video is a video of
20th of March, 2015.
Snowboarder.
And today, we're having a total solar eclipse here on Svalbard. I'm on a lonely mountaintop. Got my split board. And I'm going to try to snowboard
Svalbard.
during the eclipse. I guess that's a once in a lifetime opportunity.
This gives you an idea for what happens during the...
Now the eclipse has just started, but you can't see it yet because it's so bright, so it's going to be about an hour, then it's going to be totally dark. Now it's about 10 minutes left until a total eclipse. Still, it's super bright. Now it's only 3 minutes left until total eclipse. What a fantastic day.
You can see the sky, the shadow coming.
Oh my God. Pardon my French, ladies and gentlemen. Holy aye, this is the craziest thing I have absolutely ever seen. Oh my God! A total solar eclipse on Svalbard. This is the craziest thing I've seen in my entire life. Well, that's the craziest thing I've ever seen by a million miles. The sun is still covered about 90%. Now it's time for me to try snowboarding during a solar eclipse. That's probably never going to happen again.
Not.
I'm going to remember this when I'm a million years old.
See the shadow? How sharp it is? On a stick. Mm-hmm.
Best day ever!
This, you can see the shadow cone going. Yeah. So it won't be that cold, but it gives you an idea of what it is. So that's the talk, and I'd like to open it up to questions at this point. Yes?
When you see the final covering of the sun, can you take the filter off your optics?
Yes. Yes. As soon as the diamond ring happens, the diamond ring is very, very brief. It's safe to take off the filters. So off of your telescope, off of your binoculars, off of your eyes. If you keep them on, you'll miss it. Because the totality is so dim that if you had the glasses on, you wouldn't see anything. So you take them off, and certainly we'll have our group of people will be sort of shouting out times, so you know when first contact is coming, when the totality is coming. So you'll hear in the area, and obviously everybody will be shouting and making noise. So it'll be obvious when it's coming, and you'll be watching it too. So, yeah. Yes, you have a question in the back?
I have a serious question about the buses parking on that driveway.
Sure. Yes.
Is there catalytic converters under those buses?
Well, that I don't know specifically, because I can certainly take the question back to the bus company, but the bus is, or they bring trucks on there all the time. They bring in cattle trucks. So the trucks make it in there, it's level ground. Obviously it's not paved, but it's fairly level, and they can get, it's big semi-trailers in there to load cattle. So dry grass and dirt, yeah. Yeah, and they're going to mow it before we get there. We are bringing 17 buses to that location. We have reserved that location. We've paid the ranch for the use of the land, so it will just be our buses parked there.
And how many people per bus?
55 total possible per bus. We are filling 16 buses and leaving one empty, just in case, because you may not think of it, but I certainly think of it. If something happens, but if 2 buses break down, we're in trouble. Yes.
So this is just a hypothetical, but if you were so lucky that a coronal mass ejection happened during totality,
Ooh.
would you be able to see everything making?
You should be able to, yeah. Yeah, absolutely. Oh, I'm so sorry. I'm supposed to repeat those questions. He asked, if a coronal mass ejection happened during totality, it's a 2-minute period, would we be able to see it? And the answer is yes, if it's above, if it's ejected far enough away from the sun at that time, we should see it. Yeah. Yes.
Is there a difference between the diamond ring and Bailey's beads?
So he asked if there's a difference between the diamond ring and Bailey's beads, and the answer is no. The diamond ring is technically Bailey's beads. Bailey's beads are when the light is shining through those valleys at the end. The diamond ring is essentially the last Bailey's bead, but they were discovered they were discussed by a man named Bailey back in the 1800s, or I actually, don't quote me on that, but they're named after a man named Bailey, and the diamond ring is specifically a subset of Bailey's beads. It's a good question. Yes? Will I be passing out star charts? Well, we will be passing out information pamphlets, but they don't have the star charts. There will be one on every bus, though. So the guides will have the star charts. Yes. Well, in my experience, she asked what sort of drop in temperature can you expect? In my experience, you can expect a 10 to 15 degree drop in temperature, but it varies on the site, varies on the conditions. In Svalbard, we definitely saw at least 10 degrees. It also depends on the diameter of the shadow and where you are in that diameter. That's a good question. Yes?
With your 3 total groups, how many total people are you doing?
We are taking roughly 850 passengers, 50 guides and assistants, so about 900 people.
And
So she's asking about folding chairs. We are not providing chairs, so if you would like to have a chair with you, we do recommend that you bring one, if you can. We have 300 people traveling from overseas that may not be able to bring their own folding chairs, but you guys, I hope, have the ability to do that. We will have big buses. They're big luxury buses, and so they have cargo space underneath, and there should be room for everyone's folding chairs. So yes, and perhaps a drop cloth or something like that.
Can I add on?
Cooler.
It looks like I think on July 2nd there was a really great email that lists kind of what to bring and has your schedule and everything too. So you can search your email boxes for that. And if you don't see that, could let us know and we'll make sure you get that information.
Yes, if you are not, Julia is right. If you're not getting emails from us, you should be, or at least whoever signed up in your party, because a lot of people are part of a party. Your contact person is getting your emails. So please let us know if you are not getting the emails. You can let me know directly, or you can contact Julia and let her know, and we will add you to the list and make sure that you get them.
You just email adultprograms@dmns.org.
Adultprograms@dmns.org.
Are your 3 groups totally filled if anybody asks?
Yes. I'm so sorry. We are totally filled, but like I said, we are holding one bus empty. So, if people are there that morning and they want to sign and they want to come on at the last minute, we may have some room, but we're not actually advertising that. Because again, like I said, we don't know we may not know until the last minute that all the buses arrive safely. So, we have had to tell people that we are full. There's a waiting list on our website. It has over 400 people on it. So at this point, it's a little moot. Nobody's canceling. I think we've had very few cancellations. So, yes.
Can we bring coolers?
You may bring coolers, yes. And we will also be bringing coolers because, as you know, we're providing lunches. The lunches will be a sandwich and chips and 2 bottles of water for every passenger during the day. Yes? Rattlesnakes. He only said rattlesnakes. It's the statement. It's not a question. So the question of rattlesnakes, yes, this is rattlesnake country. Yes, we are concerned. Yes, we are cautioning that people be aware that rattlesnakes are a possibility. Keep your ears open. From my understanding, if a rattlesnake hears a lot of people and thumping feet, they'll tend to get out of the way. So we're hoping that happens. The hospital in Douglas is a 10-minute drive. I'm just saying. It's a 10-minute drive, and 911 is on high alert, obviously, during this event because everybody is going to be there. And they're stocking additional antivenom. So this is what we know. Wow. And other than that, we're just going to ask that people don't stray too far afield. Stay in groups if you can. Always be the first person or the 5th person in a line because it's the 2nd or 3rd person that gets it. Again. Yes. Intermittent. When we were there last year, we had cell service fine, but it's intermittent on the ranch. Ought to be interesting. Yes.
I assume it's okay to bring small telescopes, tripods.
Absolutely. This is going to be like a large telescope party. He asked if it's okay to bring small telescopes, tripods. Yes, please do. It's going to be fun. You'll have a lot of people visiting your station, checking it out. Yes. Well, okay, so she asked about driving time and traffic. So this is obviously a very good question and one that's impossible to necessarily predict accurately. But we have bumped up our departure time with concern that we will run into a lot of heavy traffic. The following is what I know. I have spoken to the Wyoming Department of Transportation. I've spoken to the Colorado Department of Transportation. They're both aware of the event, more aware now than they were when I called them 2 years ago. Um, so, and they have Wyoming at least has a department now handling the event of people. They have agreed to suspend construction during the time, so all the lanes of the highway will be open. They are treating it like an event, like a football game or something like that, which the roads are able to handle that. We know that when there's a game between CU and Fort Collins, there's a lot of people trying to go up to Fort Collins for those games, and they manage to get them there and get into the stadium before kickoff. So we know that the roads infrastructure, the infrastructure here can handle a heavy traffic. We have rush hour every day in Denver. The source of traffic is essentially the Front Range, which is 4.5 million people. It's a working day, a Monday. Schools start on the 15th of August, at least in Boulder, and I think that day here. So between school starting and working, being a work day and people having to request the time off to get it, I think that's going to reduce the number of people that are trying to drive up there. A lot of the people who are going may already be there. So of the people that are going to wake up at 3 o'clock in the morning and clog the roads with us, then you have to consider if they've never seen an eclipse, the alarm's going to go off and they'll hit the snooze or just decide, maybe not. I'm not up to 7 hours of driving today. So you never know. But we're hoping that we have banked in enough time to have full stoppage for 3 hours and still make it. So, I don't know what else we can do.
With events like that, you usually got tow trucks and, emergency vehicles stashed around so that stoppage is maybe going to clear out the accident and that kind of thing.
I sure hope so. Yes, I mean, with an event like that, they usually have things like emergency vehicles and tow trucks spaced out and available. And we're hoping that certainly is the case, that they will be able to clear any block. It's summer. The roads are going to be dry and beautiful. If this was winter and imagine one foggy morning and a sequential crash would do us in. But no, I think we're in pretty good shape. Couldn't pick a better time of year for this to happen. So these are very good questions, and you all share my fears, I guarantee you. Yes, you had a question? Somebody? Oh, you're right here. Sorry, I didn't see you. You're waving.
I wonder if you have an estimated time of return.
Yes. So the eclipse goes until 1:11. It ends, fourth contact, and we will be, everybody is probably going to be picking up and starting to get their gear together after totality, which is around noon, 11:30, 11:45. And so as soon as totality is over, people will start to collect their things. And I'm guessing many people will already be on the bus. We're hoping to be on the road by 1:30 because we do need to wait. A lot of people will be doing photographic projects and doing things up until the last of the eclipse. And then we'll try to get everybody on the buses. As the buses fill, and we are going to make sure that the same people are on the same buses going down. We don't want to leave anybody behind, obviously. Then we're going to head back as soon as possible. We're telling people that we'll get back by 6. We're hoping, if traffic is light, it'll be 5. We'll get back. It's a 3.5-hour drive with no traffic. So now everybody and their brother is going to be on the road going back. So it may be worse traffic on the way back than on the way up, because all those campers are leaving as well. But yes, you have a question.
I'm interested in the coordinates, longitude, and
Yes.
latitude will be stopping. Would you be able to send those out?
Yes, and I believe I have sent them by email already. You should have them, but I have them here, and I can give them to you. Or actually, one of the guides in the back. Oh, I'm so sorry. He asked about the coordinates, the exact coordinates of the site. So I believe that's already been emailed, but I will resend it, and I can give it to you. Oh, you've got it. Never mind. He's got it. Yes, and so if anybody else would like it and you can't find it, let me know. I will resend it as well. You have,
You know, there's a smartphone application app.
oh yeah.
It's called Eclipse Timer. Do you know about that?
Oh, yes, he's asking about an iPhone app or a cell phone app called Eclipse Timer. Yes, and there's a cell phone app called Eclipse Timer, and it gives you the exact times and statistics for your location. You had another question?
Yes. Do you know what the plan is? And I mean plan as to what exit we're going to get off going up?
I don't have the exit number on me. It's Douglas.
Okay, because,
Yes.
and there might be quite a, like you said, a lot of traffic even going into Douglas.
Yes.
I'm thinking half of Cheyenne
Right.
is going to be up there. Okay.
Yes. So he's concerned about the off-ramp at Douglas. Again, I think we're going to run into more traffic by Glendo. We are planning to stop at a rest area in Orrin if we get there before 8:30 in the morning. If we're running late and we get there after 8:30, we'll bypass that stop, but we would like everybody to have a chance to use a proper facility before we get to the fields. So we're planning on stopping at a rest area in Orrin, which is after Glendo but before Douglas. It's about, I think it's about 20 minutes from our Eclipse site. If it's 8:30 already, then we may bypass that and just go straight to the Eclipse and have people use the bus. Another question?
Before I ask my last question,
Sure.
I'd like to thank you very much. You have covered a lot. You've had experience in similar
Yes.
circumstances.
You're welcome.
I was going to ask if there was an alternate site, but it looks like the weather should be.
The weather should be clear, but yes, we do have alternate sites planned. We've identified four alternate sites. Now, the problem with our alternate sites is that we haven't rented ranch land at our alternate sites. So the alternate sites we've selected are basically stretches of road. We've tried to find stretches of road that would allow us to get the access with buses without blocking bad traffic. But
Is the museum bringing any telescopes or equipment for general?
it's a very good question. Is the museum?
We are not. Our telescopes will, unfortunately for us, be in use here on site for programming during that time.
Now, my experience is that a lot of the travelers will have equipment, and you will see a lot of equipment set up, and people are generally very friendly and very willing to show you what they've done and what they're doing, unless they're actually fixed on looking through it at all times. They'll show you, let you look through their telescopes. Like I said, it's like a big eclipse, it's a big star party during the day. So, does anybody else have any questions at this time? No? Thank you for coming. And if you have any other questions, send them. Don't know. Let's go back and see.